To be honest with you, what we just did. 9-6 becomes a lot easier. The reason why it becomes a lot easier is that when you're working with common denominators to solve equations, you're eliminating your denominators. You still have to find that common denominator, but in the long run, you're getting rid of it, and things become a little bit clearer. You're going to notice the main difference between what you were doing yesterday, multiplying terms by factors of 1, common denominators like that. Whereas today, we're multiplying both sides of an equation by the same thing to keep things balanced. It's the same principle here. So if I look at something to start out like this, x over 3 plus x over 4, and I want it to equal 7/4. And I need to solve for x. Well, what I want to do here is figure out what is going to be my common denominator between a 3, 4, and a 4.
12.
Are we okay with that?
Yeah.
So by using a common denominator, and I multiply both sides of the equation by 12.
Why don't you just make it 4x plus 3x?
Getting there. I'm showing how that works. By multiplying and distributing all three parts here, the 12, because I'm keeping things balanced on the equal sign, you get the following. 12x over 3 plus 12x over 4 equals 12 times 7 over 4. Now, Christian, what I'm doing here, I'm doing the long way. You've already done it in your head. You're fine if you want to do what you just told me, because it's right. Okay? When I'm looking at these, you should notice right away that you can simplify each one of those fractions, and the fraction goes away. What's 12 divided by 3?
4.
You get 4x. What's 12 over 4?
3.
You get 3x. And then this becomes 3 times 7, which is?
28.
Try again.
21.
By multiplying through to everything with your common denominator. What's that?
Wouldn't it all be over 12?
No.
Oh.
It's not over 12 because it's 12 over 1 you're multiplying by. We're not multiplying it by a factor of 1, whereas yesterday we were multiplying it by 12 over 12 to everything.
Well, no. It's just like finding the greatest common denominator. Why don't you just make 3 into 12 by multiplying it by 4 and multiply the numerator by 4?
Because then you still have a denominator.
You still have a
Yeah,
denominator.
they're all the same.
Right, but by doing it this way, you eliminate the fraction completely.
Who can you do that at the end?
If you want, but this is a lot cleaner. It's less likely to screw up. It's a lot cleaner of a method. So now you get something that's really easy to work with.
X equals 3. I love it when you go through something really, really complicated and then you just get to like something like that. It's so beautiful.
It's lethargic.
That's fine.
Not lethargic,
It's
it's
just like the
cathartic.
promised land. You
whatever.
made it.
I'm making words up.
Yeah.
All right, let's try another one.
For the words being something really complicated.
Once you get a term equals a term, then you can just multiply the sides of the 12 and satisfying.
It's true, and that's one of the methods. And I'm not going to say there's one way better than another, and that's all right. All I'm saying is that sometimes if you do it this way, especially when we get into the ones you have to factor first, it's just going to be a lot cleaner. That's all. All right. So here we've got x over 3 minus x plus 2 over 5 equals 2. I want to get rid of the fractions. The least common denominator of a 3 and a 5 is 15. So if I set this up by multiplying everything here by 15, I get 15x over 3 minus 15 times the quantity x plus 2 over 5 equals 15 times 2. I have that 15 distributed to every single term in the entire equation. Therefore, everything is balanced. What I've done to one side, I had to do to the other. Now, I can simplify these fractions. What's 15 over 3?
5.
So you have 5x. 15 and 5 simplifies up to 3 times the x plus 2. And I equal 30. Do a little distributing. You should get 18. Got that negative, didn't you?
Yep.
That's where you're going to screw up. Careful when you distribute out a negative. Now, eventually, what I want you guys to start to notice, if I'm multiplying everything here by 15, which is the common denominator, this fraction is going to go away, so what does the numerator just become? 5. 3 times 15. Eventually, I'm going to start stopping writing out this intermediate step. Just no need for it. You should be able to do that in your head. Okay. Same idea.
Oh, you have to put it over.
You don't have to, if you'd like to.
Wow.
Get rid of the fraction. Get rid of the fraction when you multiply everything by 3. You multiply everything by 3.
So you just get 18.
Oh. Oh, because that one's over. All right, dang it. I put it 105 instead.
No such thing as a decimal.
Does it get any harder than this?
Oh, God, yeah, of course it does. It's not as satisfying. Okay. Stop going to humanities. You can't stop looking at water bottles.
She's trying to understand how.
Now, let me show you a little trick here. When you're writing this one out, 4 over x plus 5 over 2 equals negative 11 over x. What I want you to do is anytime you have something with a negative symbol, make sure you put it to the numerator. It helps keep things a little bit cleaner. Okay? Make sure you put this here. I know how to use this word. When you have a negative value, what is the negative in the numerator? It's just easier to keep track of. Okay. So what's going to be your common denominator between an x, a 2, and an x?
2x.
2x. So what are you going to multiply everything by?
2x.
All right.
Probably 6.
So the first fraction already has an x in the denominator. So what do I just have to multiply it by?
Oh,
Wait, what?
Hold on.
Oh, wait, then again. You just like skip
The second one has a 2 in it. What do I have to multiply?
X.
You just like skip a step. Okay.
Oh, it's a. Oh, so you get rid of the denominator on the.
You get negative 6. Okay? Now, what's nice with these things is you can also check your work. You have a calculator. If you substitute in for x in a calculator, 4 over negative 6 plus 5 over 2. Alpha y equals. So when I substitute in, I get 11 over 6, but it's supposed to be negative 11 over, what's x though?
Oh.
It's negative 6.
Oh.
So is this a valid statement? Is that the
Yes.
same as negative 11 over negative 6?
Yes.
So did it work?
Yes.
Yeah.
You have to remember that.
Yeah, there's little things, little subtle nuances about checking your work there to make sure it works. Because sometimes the value of x that you find may look like it's a solution, but yet it's not a solution. It's called an extraneous solution if that occurs. It's an answer, but it's not the right answer.
What?
Well, think of it this way. What if your solution created a 0 in the denominator? Can you divide by 0?
No.
No. So it was a solution, but not a solution. You did. Yeah, you had the extraneous solutions in geometry when you had some problems where you had the quadratic, where you have like a negative value, you can't have a negative segment length. Yeah, that happened.
Another
Ooh, X minus 2.
So everybody's already mumbling this around, I believe, that your common denominator is going to be what?
X minus 2.
So what do you have to multiply everything by?
X minus 2.
Okay.
Except for 5x and 10.
So you multiply everything here. First fraction has an x minus 2 in the denominator, so it doesn't need anything, so you just write out the numerator. The next one needs it. The last one doesn't. Yeah.
You can still technically go through and do it. And
Yeah.
Okay.
You just space, that's all. So now when I do this, I get 5x equals 7x minus 14 plus 10. Moving stuff around, you get 4 is 2x, so 2 is x. Go back and look at your problem then. Can 2 work?
No.
No. What happens?
0 in the denominator.
And can you have 0 in the denominator? No. So you found a solution, but it's not a solution. So it just doesn't work. There's no solution.
That's really weird.
Yeah, it's just no solution. 2 is an answer, but it's called an extraneous solution because it doesn't work.
How do you spell extraneous?
I have no idea.
E-X-T-R-A.
I'm not gonna write it.
Don't you think?
I think so.
E-X-T-R-A-N-E-L-U-S. I don't like the E in it. I don't know. No, there's not E there. What the
E-X-T-R-A-N-N-E.
Wait, what are you?
Why are you stop it? There's no I.
Not right.
It's like extraneous.
T-R-A. Stop!
Oh, I think it is I-O-U-S though, like without the other
That
I.
doesn't look right.
I think it's the IAS.
I'll look it up.
I
This is
think-
how it's spelled.
That's probably wrong.
No, look,
You guys are
That's
wrong.
what I'm saying.
Could be an I thing.
No, that's right.
That's right.
That's what I'm saying the entire time.
so what do we do in that situation? We just say.
No solution. It's fine.
Extraneous.
All right. I'm sorry. I'm sorry.
Actually, can I go home?
Do this one. Now you have to start paying attention about possible factoring you might have to do.
And then
Wow.
Everybody agrees that your denominator, your common denominator to multiply everything out, x plus 1, x minus 1. We okay on that? What's that? When you factor this, you get x plus 1, x minus 1. That's over 1. What do they have in common? X plus 1, x minus 1. That's all we're looking for. Okay? Yeah. No, I wouldn't do that because if you do that, you're gonna have to wind up simplifying something out later on. You're looking for the least common, the fewest that they have in common. It's always cleaner that way. So the first fraction, what was it missing?
The x minus 1.
So you wind up with 4x plus 1, x minus 1, equals 12 plus 3, x squared minus 1. What I'm doing there is, I know that my common denominator is x minus 1, x plus 1, but that really is x squared minus 1. I'm just shortening up my workload here by writing it out like that, just quicker. All right, that's all I'm doing. Now I'm going to distribute and combine like terms on both sides of the equation, see what happens. 4x squared minus 4x plus x gives me plus 3x minus 1.
I got minus 3.
Sorry.
Because I got 1 minus 3.
Jeez. Vicious back there. Here you get 3x squared minus 3, so you have 3x squared plus 9. Don't throw anything at me if I'm wrong.
What if you're writing then? Can we throw stuff at him?
No,
Wait,
nobody's
don't
asking
you
you.
need the 12?
Joking.
Yeah, so you need the 12.
No, he already factored that in.
Did you? The 12.
What's 12 minus 3? Okay. Now, notice how you've got variables on both sides of the equation, and you've got squared terms on both sides.
Oh, 9.
Set it equal to 0. What?
What'd you do?
Guys, sorry.
What'd you do?
What's 12 minus 3? That's what I did. Okay. Move everything to the left. You'll have to factor to find your zeros.
5, -5.
Still gonna be able to solve for x here.
Negative 2.
What times what's negative 10? You add together, you get negative 3.
Negative
What is
5
it?
and 2.
Negative 5 and 2.
I think there's one correct, right?
So your two possible zeros and what, Christian?
I think they both work, right?
I think these do okay, yeah. You have 5 and negative 2. Yeah, because you're not going to get 0 in either denominator, so that's going to be okay. That's usually all you have to worry about. I'm pretty sure that's, yeah. What's that?
Because I knew.
There's no y equals. It's usually setting up and solving. Okay. Okay. You wind up graphing through, or not graphing, you wind up going through. Let's do another one like that.
Wait, can you not hold on, yeah.
Number 2.
Thank you.
Yes.
That sure is actually kind of scary. The way the room felt.
First way I see this, isn't this fraction equal fraction?
Yes, the fraction equals another fraction.
Oh, so you can cross multiply.
In this case, you could cross multiply because it's fraction equal fraction.
I didn't get that far.
Okay? That's one way of doing it.
I love cross multiply.
In this case, since it is fraction equal fraction, you could cross multiply. When we were doing stuff like this, it was fraction equal fraction with something else. Can't do it. If it's fraction equal fraction, it's one method to do this. So you wind up with 2, x minus 1 equals x squared minus x. 2x minus 1, or minus, excuse me, minus 2, which you got to bring over here. So I have 0 is going to equal x squared minus 3x plus 2.
No, it's.
You're right.
So when I factor that, I get
2 and 1, negative 3 minus 1.
No. Wait.
I didn't get one. I didn't get one.
Because you had to bring it over. What is extraneous?
1 is extraneous.
Oh.
1 is an extraneous solution
We did it.
Oh, so is that
because 1 squared minus 1 is 0.
Is that why if you did it the other way, you didn't?
If you did it the other way,
You only get it.
what's your common denominator between the two? x
X
and x minus 1. So if you multiply both sides by x times x minus 1, this side already has both. This side needs,
X.
So happy with this.
sometimes it's that easy. Yes, ma'am.
Why would I understand why x times x minus 1 is always going to be denominator, because it equals x squared minus x. So you just put that all on the outside?
Yeah.
Okay.
Because by multiplying everything on both sides of an equation by the same thing, it just so happens that it's going to eliminate both denominators, which gets rid of the fractions, which usually makes you guys smile. That's one way of doing it.
Yay!
This case here, when you did it, if you go about this way, sometimes it just drops it right to that and you're done. Okay? Let's do some problems. Excuse me. This is section 9.6. It was numbers, oh, what was it? Make sure I did the right ones.
Yeah, do we have any Western Union?
Just to finish the worksheet if you didn't.
I missed questions, actually.
I hate it. I hate it.
It's actually really fun. You think it's bad?
We have a lab team.
No,
I touched
I'm not. Well, Mr. Chow gives us quizzes like every day because all our
Yeah.
because you get hurt.
And he doesn't care.
And he,